Great. Awesome. Okay, well, thanks again for joining. And before we get started, first, we'd like to take a moment to acknowledge the traditional owners on the lands that we're meeting today, including the Ugambe people, which is where I am on the Gold Coast today, and the Ngunnawal people of Canberra, where my colleagues are sitting. Um, I would also like to extend my respect to the Aboriginal and Torres Strait Islanders everywhere that we're sitting today, including elders past, present, and emerging. And I'd like to recognise their contribution to science and the data that we're using today. Okay, so we're going to get started, and I'm going to start sharing my screen. Okay. Yeah. Okay, so I hope that everybody can see my RStudio on here. And I can't see the chat, so I'll just keep going until someone interrupts me, and we'll try and take some little breaks here and there so it's not too fast. But the team just tell me to stop talking and we'll go from there.
Screen sharing is going fine, Jenna. Looking good.
Great. Okay, so first things first, hopefully everybody has set their working directory. And the first thing we're going to do is install the packages that we need. So we're going to get started. So the first package we need to install is our wonderful galah package. So we're going to do install.package and put galah in our quotations there. We're going to run that one. I'm just going to update mine because I've already done a bit of a practice session. Okay. And the next one we're going to do is we're going to install a dplyr. So this is another package that we have a few dependencies and things with. So we're going to install that one as well. Okay. So once we have those two packages, we're going to add our libraries. So this one, we need galah and we need dplyr as well. Okay, so we're going to run those ones. If you're not super familiar with R, but you're already set up, to run the line easily, I use Command Enter on the Mac. Or you can hit Run up here as well. Okay, I might just hold and just check that we're all okay with this so far with the packages and things, and we can start diving into our functions. I'll take no news as good news as well. Okay, that sounds great. All right, so let's introduce galah package. So the galah package was built so that our users can access all the wonderful data of the ALA, so all of our biodiversity and occurrence data through R. So R has become increasingly important and widely used in the scientific community. So our team thought, why not put all of the great data and things into this package so you can easily access it without having to go onto the web platform. So it means that our work can be repeatable and transparent. So you can include your code in your papers and your workflow. And it's just a really neat way to access that data. So the functions you'll see here today are very similar to the ones that you would point and click on the web platform, but just in code form. Okay. So to access data on the ALA, which you might already know by going onto the web platform, is that you need to sign up. So once you've signed up, then you can access all of that data. Through the galah package, you still need to kind of do that. And so what we need to do is we need to add our email to this kind of workflow. And to do that, we use a function called galah config, which is just configuring your code so that you can access the data that you need. So in galah config, we're going to put email equals, and then you need to put your email in here, the one that you've signed up to the ALA with. So I'm going to put mine in here. Feel free to reach out to this email if you have any questions as well. And I'm going to run this one. We need to put it in quotations. That's a good start. Okay. Alrighty, so now that one is set. So now when I access data, it's going to be recognized through my account. So while you're sorting that one out, I'm just going to show you just a little trick if you need more information. So if you ever need more information on the package that you're using or a function, you can use the help function, which is just the question mark followed by the package or the function that you want to check out. So I'm going to run that line there, so question mark galah, and then down here, sorry, I just have to move this here. And you can see down here in the help, you've got all that information from our vignette and our sources. So you can go through this at any time when you get stuck, and you can go through all the functions we have, and you can search for information there. And just it can help you along the way. Okay. So the next thing we're going to talk about is which atlas to use. So here at the Atlas of Living Australia, the default atlas is of course the Australian one, but there are actually other atlases across the globe. So the galah R package is currently tapping into a few of these, and you can actually change which atlas you want in this package. So we're going to do that one now. So let's have a look at which atlases are available. Okay, so this one here is a function called show all atlases. So if we run that one, so in case it's going a bit quick, if you start to type out a function, it will likely automate and tell you which one you want to do. I just click enter and it kind of pre-fills that one out. Just makes it a bit easier when you're doing a lot of typing. So command return, and I can see down here in the console all the different atlases that are currently available through the galah package. So we have Austria, Guatemala, Spain, Sweden, and the UK. So you can actually change the atlas from the default of Australia to one of these ones if you want to access data from there. And to do that, so if you want to change the atlas, we're going to use that galah config function again. This one here. And in this one, we type atlas equals, and in quotations, we type, let's say, Austria. And if we ran that one, it would switch our atlas that we're getting data from to the Austrian one. But I'm not going to run that. I'm going to stick it with the Australian one today. Okay, so let's move on from that one. So now we've configured our space, we've got the Australian atlas, we've put our email in, and now we want to start looking at some data. So first, it's useful to know where to find the information that you're going to filter your data queries with. So galah uses what we call fields to narrow down our data queries. And each of these fields has its own values or categories that you can use to filter your data. So by field, we mean the column that's in sort of the CSV that you would normally download. And there's hundreds of different ones you get. So if you've ever downloaded ALA data from the web platform, you'll see that there's hundreds of columns and each one of those is a different field. So this could be something like year, it could be basis of record, or it could be event date. Okay, so now we're going to look at how we can view all the possible available fields. So this starts to get a little bit tricky and they're quite a lot to look at. So we're going to introduce the pipe function here as well, so we can view all of the different fields in a table. So here, I'll show you what I mean by the pipe function as well. So if we do show all fields is the function that we need, like this. If we were to just use this one, it would only give us a few and it would say there are 933 other fields. So what we want to do is we want to use the pipe function, which can be in two different ways. So you can use a pipe that looks like this. So the straight line and the forward arrow, and that one comes from the base R, or you can use this one here, which comes from dplyr. And you can use either one, both will work the same, it's whatever suits you. So on this one, if we use this pipe function, which I like to think of, it says and then. I think that's how I always think of it. So and then I want to view that information. So I'm going to use this function here with an open and close parentheses. If I run that, it actually opens up a nice table. So then I can scroll through all the possible fields we have, which if we go right to the bottom, 943. So there is a lot, but you can search through this. You can filter it to find the different fields that you want. But that's quite handy to refer back to when you're building your queries. So some fields like, I guess, year and event date, they're quite self-explanatory. You can type a year and it makes sense. But some fields are not like this and they're a bit more complicated. So some are built with a unique code instead of a name. And this code is because the ALA searches for this information internally, and it was easier to use codes rather than long-winded names. So we have to use those as well here in galah. So that means you'll have to find those codes within the data. And I'll show you how to do that. So here we're going to use the search fields function. This one here. And you can type in things in here. So I want to look for Australian states and territories. I'm just going to write Australian states. I'm going to run that one. And I can see here that there are two possible layers that I can look into. And see here on the left, you can see these codes. And that's what we're talking about. So we actually need to find those codes and then use that in our lines to build our queries. So once you know that field code, you might now want to know what's inside that. And for example, you might want to see a list of the possible states and territories that are within this CL22. And the next function we're going to learn, which does that, is search field values. So we're kind of going from like a funnel. So a really large category, all categories, smaller category, and then what's inside that category. So then in quotations here, I would write CL22 and run that one. So we can see inside this Australian states and territories layer, we have the following states and territories. And that's just really useful for us to know if we want to filter down by something really specific later on. How are we going in the chat? Are we all good? Fabulous. Thank you. All right, so now we're going to move on to narrowing our results. Okay, so each occurrence record that we have contains taxonomic information and information about the observation itself. For example, location, latitude, longitude, and date of observation. And these pieces of information are recorded and categorized into those respective fields. So when importing data using galah, the columns of this table respond to these fields. And the more we add and the more we filter out, I guess we're getting the data that we really want and need and not everything that's available. So we have quite a few functions that help us to do this. We have galah identify, filter, group by, geolocate, and down to. And these function names have been chosen with purpose. So they are comparable to the functions of dplyr, mostly filter, select, and group by. So it can be quite handy if you are familiar with those packages and things and that particular syntax. It'll be quite easy for you to pick this up. But if not, no worries. We have lots of documentation to step you through each of those. So we're going to start using two functions, and these are called galah identify and search taxa. So the first thing we want to do is we want to search for which taxa we want our data. So with scientific names, you know, they can be quite complicated. You might have spelling mistakes. So the first thing I like to do is check that I'm actually searching for the correct taxa. So our next function, search underscore taxa, like this. And for this example, I'm going to search for reptilia. So we run that line, and then we can see here that we have reptilia is the right scientific name. And now I'm happy that I can start building a query based on that taxa. You can also get more specific. So we can add a data frame and we can break that down. So we might want to get a particular genus. So let's add a data frame. Yeah, so I'm going to type search taxa. And in here, I'm going to use data.frame. Yeah. And then I'm going to type in genus. So for this example, because we're the galah workshop, I'm going to use the genus for galah, which is, I think, Elephas. Please excuse my pronunciation. And I'm going to specify that it's in the kingdom equals aves. And this is really useful if there are names that occur in multiple different groups and things, you can really specify what you're after. Okay, so we just make sure they're in quotations and we have those equal signs. I'm going to run that one and we can see that's great. This looks like the right taxa. Okay. So once you're happy with the selected search terms that you have and you've got your correct taxa, you can start to use galah identify to narrow down your search. So to begin building a data query, we first always use the galah call function. And this works by creating a blank list with all the subsequent lines adding to that list to narrow down and filter the data that you're getting. And then we always finish with an atlas function. So the atlas function for this example will be atlas counts, and that will give us the number of records. Or you can do atlas occurrences, which will actually give you the whole suite of occurrence records. And we also have others like atlas media and things like that. Okay, so let's start with an example and build our first proper data query. So I want to find the numbers of records for all reptilia. Okay. So to do that, we start building our query first with galah call. So galah underscore call. And now at the end of all of these lines, so after each of these functions, we have to add the pipe. And that just allows us to say, and then. So I'm going to add the pipe here to say, and then I want to use galah identify, which is our next new function, to search for reptilia. And then we finish with a pipe to say, and then I want the atlas counts. So this is how we finish, like this. And I'm going to run that one, and we're going to see that for all reptiles on the atlas, we have about, what is that, 1.4 million records, I think. That's great. So you can do that with any taxa, and you can see how many records. And you can also create a more complex search, and you can sort of search for a specific taxa. You can save that as an object, and then you can use that object in your call. So instead of just searching for reptilia, we could have already done that. So I'll show you. Create an object. Okay, so I'm going to call my object taxa, and I'm going to use the assignment operator to create an object there. So that's the backwards arrow and the dash. And then we're going to use our search taxa function, like this. And we're going to add that data frame again. So data.frame, like this. And then just like we did before, I'm going to put in a more complex search. So I'm going to do genus, I'm going to do Elephas, and kingdom equals quotations, aves. I'm going to run that one. And what we should see is up here in our global environment, we have that as an object now. So we can actually click that if we like, and we can see that we have this object here. Okay. So now let's use our object in our next call. Okay. So again, we're going to start with galah call, like we start all of our functions. We're going to add our pipe to the end, and I'll just give you, if you do Command Shift M, it's a bit of a shortcut to getting this pipe. Might be a bit easier. So to say, and then I want to use galah identify, like this. And instead of putting in quotes, sort of a search term, I'm going to put in my object here. So I'm going to put in taxa. And then we add a pipe to the end. and finish off with atlas counts. So now we can see how many records of galah we have on the ALA. And we can see here we have over 900,000 records of galahs, which is great. All right. I'm going to move on now to a function called galah filter. So galah filter is probably the most useful and the most important function that we have here in the galah package, because this allows you to filter with a whole suite of different facets. So if you're familiar with the web platform, when you're searching for a species and you can filter down on the left-hand side, all those different facets, they're all available to you here in the galah package. So let's dive in and start with an example to start with. So I want to get the total number of records on the ALA since the year 2000. So to do this, we start by building our call with our galah call function. We add our pipe to say and then. We want to filter like this. And I want year is greater than 2000. I'm going to add my pipe again to the end, which is Command-Shift-M. And then I'm going to finish off with an atlas counts. Okay, so let's see how many records we have since the year 2000. And we have a whopping 73 million records on the atlas since the year 2000, which is huge. So now we can go a little bit further with this function, and let's add a couple more filters so we can really wean that down a bit. So let's say, for example, I want all the records on the ALA since 2000, but only those uploaded from iNaturalist Australia. Okay. So to do this, we start off the same way. We do galah call. We add our pipe to say, and then I want to filter like this. And I'm just going to go down a line here to make it easy to read. Okay, so the first one, we want the year. So let's do year is greater than or equal to 2000. We put a comma to add our next filter. So I'm going to go down a line again, and then we're going to add data resource name. Okay, so I know that this is one of the fields that I can search from the previous functions that we learned at the start, which was search or fields. Okay, so now I use two equal signs and then the quotations, and I put in here iNaturalist Australia. And then we put our pipe to say, and then I want atlas counts. So how many records since 2000 from iNaturalist Australia? And we run that one, and we have around 3.3 million records that have been uploaded from iNaturalist to the ALA since 2000. So you might be interested in how I got to iNaturalist Australia from the data resource name. So you might actually want to go into that field and see all the available options you have. So I'm just going to show you how to do that. So we want to see what we've got here. Okay. So search field values is a function that allows us to look inside a field. So we're going to put that one here. We're going to type in our data resource name, and just it does have a capital R and a capital N to make it complicated. And then just to make this easy, I'm going to put this function called limit equals, and I'm going to put 1000. And that's just because the default limit of the list will be about 20. And I know this one has a lot more, so I'm just going to add that. I'm just going to add the pipe here to then say view. So we can see what this looks like in a table. Okay, so I'm going to run that one. And we should see here in this table, in data resource name, we have all of these options. So I've picked this one here, iNaturalist Australia, but you could choose multiple, all, or just one of these following ones. And there's quite a lot here. So these are all of our data providers. We've got 857 at the moment. Okay. So I might just pause for a sec and just see if we have any questions that are good for the whole group or if we're all good. Great. Okay, I guess we'll keep going. So the next thing we're going to look at is profiles. So it's often important to remove spatially invalid records from a search. So for example, you might have a desert species that looks like it's occurring in the ocean, or maybe it will be something that keeps occurring in botanic gardens, or it's already been flagged by the ALA as being inaccurate. So you can use the galah package to remove these records using ALA profiles. Okay. So let's first take a look at all the available profiles that we have. Okay. So we're going to use a function called show all profiles like this. And we're going to use that pipe function and view just so we can view those in that table. So these are the available profiles that we have. The one that we recommend our users to use is the ALA General. This one has been developed through engagement of stakeholders and scientists to develop sort of what we think is a best practice for a first kind of sweep at data quality. So this one here is the one, that we would recommend. The other ones have been sort of developed quite specific for different projects, so we'll recommend this one. So I'll just, when we look at this, the short name I'm going to use in the next function. So this one here. Okay. So I think it's pretty important to understand what's happening in these profiles so you can accurately report on your data. Okay, so the next function is called search profile attributes, just like this. And we're going to use the pipe function. So in here, I'm going to put ALA because that was the shorthand name for this profile, or ALA general. Okay, we're going to add the pipe here at the end. We're going to do view, and let's take a look at what's happening inside that profile. So we can see here, this is a list of all of the things that it's doing. So essentially it's removing any record that has issues with the name, if it's been flagged by users, if it's a record collected prior to 1700, which is just way too old, if it's flagged as an absence instead of a presence, if it has uncertainty, if it falls definitely outside of its distribution range, and if it's missing information like latitude or longitude. And I recommend you, if you're going to use one of these, maybe to pop onto the ALA website, and our support pages cover this topic really nicely. Okay. So let's use an example with profiles. So let's look at all the records from the year 2000 that are spatially valid. Okay. So to do that, we're going to start like we do with all the other ones with a galah call function. We're going to add our pipe to say, and then I want to use galah filter like this, and I'm going to use year is greater than or equal to 2000. I'm going to add a comma here to do my next filter, which will be the profile. So I type in profile equals, and in quotations, I put ALA. And then we add our final pipe followed by Atlas counts to finish. Okay, so let's run that one. So we can see here by adding the profile, we get around 68 million records. So if we remember what we got, so I'm just going to remove this like this. So if we remember 68 million, if we take away the profile, we get 75 million. So by adding that profile to remove what we call suspect records or spatially invalid records, we're removing quite a few million records from that list to get 68 million. So this is a really nice way to kind of do that first sweep of data quality checks on your data, and hopefully that will just make it easier for you when you start analyzing. Okay, how are we going? Do we need a little moment?
Going well, I think, Jenna. A few questions in the chat, but nothing too urgent, I don't think.
Okay, great. We'll have some time at the end too. This is a bit of a whirlwind tour, but we'll have some time for questions where we can have a chat once we're done. Okay, so the next one we're going to do is a function called galah group by. Okay, so this one allows you to group your records really neatly. And so, for example, you might want to look at records in 2015 grouped by data resource name or basis of record, for example. And it's just a really neat way to view your data. Okay, so let's start with an example. And let's get all records for galah. Okay, records for the galah species since 2015. And let's do 2015 to 2021, just to get tricky. And grouped by year and basis of record. So basis of record is what type of record that is. So it might be human observation, it might be museum specimen, it could be fossil record, things like that. Okay, so let's get started with our call. So galah call, and we're going to add our pipe, and then we're going to use galah identify. Yeah, and in here I'm going to pop my species. So we're going to use galah again. So hopefully I spelled that right, Elephas. And it should be Rosy Capilla. Again, sorry for my pronunciation. Okay, hopefully that's correct. Okay, we're going to add our pipe to then say and then. We're going to add our filters, so galah filter. Okay, we're going to do year is greater than 2015. And I'm just also going to add an and in here, so you can get more specific with your date ranges. And I'm going to do year is less than or equal to, and let's do 2021. We add our pipe one more time. And then I'm going to add the new function galah group by. Okay, like this. We're going to add year and basis of record, which has a capital O and a capital R, just to keep it spicy. Okay, we're going to add a final pipe, and we're going to do Atlas counts. Okay, and let's run that one there. Okay, so this one takes a little bit longer because we have quite a few filters, and we can see here that now our information will be grouped by basis of record and year. So it makes a really neat way of visualizing that data. Okay, so now let's add something to this. Let's create an object for this call. So I want to create an object so I can go through and I can visualize that data and I can save it. I can create a CSV. And then I'm going to show you how to get, so this is counts, but then I'm going to show you how to get occurrence records. So let's call, I'm going to call mine galah occurrence data. I'm going to add the assignment operator, so the backwards arrow and the dash. Okay, and I'm going to run that one. So we're going to be able to see that over here. We click this one, so we can see that how it's all neatly grouped, all of that data. Got machine observation, preserved specimen, material sample, and a few others. Okay. So now that's given us the counts, but most of us are probably going to want the occurrence records. So at the end here, instead of using Atlas counts, let's use one called Atlas occurrences. And once you've done that, we're going to hit run. This one takes a little bit longer. Okay, but I'm going to, oops. I'll run that one. And, oops, I think we're running everything. Okay. What have we got? Galah identify.
I don't know why that's throwing a bug, Jenna, but it might be that group by isn't accepted by Atlas occurrences. So you could try commenting that out.
Oh, yes, good point.
It looks
Yes,
like you've accidentally run that you're trying to get the Austrian atlas because it ran your whole code. So you have to switch back to the Australian atlas.
Oh,
Yes,
what
you're
it does.
right. I see. Okay, so we want galah config. This is great. We can try and remember. So we want Atlas. Atlas equals Australia. I think hopefully that works. Okay, and then let's try this again. Excellent. Thanks, Dex. Okay, so we can see here this query is going to return around 300,000 records for us. So once that's finished, I'll be able to show you what that will look like. Just give it a sec. Okay, so if we click on this one, we can see this is kind of what our CSV will look like. So it's got your standard latitude, longitude, event date, scientific name, and this information here. And it's got the data resource. So that's a lot of information, and it's likely that you're going to want to create a CSV with that one. So you probably already know how to do that, but I'm just going to add it to the end here as kind of a neat way to finish this live coding session, and then we can dive into all those lovely questions that you have. So I'm going to just use the write CSV function here. I'm going to add here my object that I created. So it was galah occurrence data, like this. I'm going to do a comma, give that a file name, and let's call it galah occurrence.csv. And if we run that one, I'll be able to show you it should turn up in our files here. So now I have that CSV on my local computer, and I can analyze and do whatever I like with that one. Okay, I think that kind of covers the main things I wanted to go through, and I wanted to give us sort of 15 minutes to have lots of questions and a discussion on anything that you might have. So we might jump to that now. And I can stop sharing. Feel free if you want to like just jump in, just unmute yourself, turn your video on. That would all be fine.
I'll just jump in there too and say we might stop recording now, so you don't need to feel shy. Any questions are welcome.